Так. Нету, кого-то не хватает. Who are missing, guys? Бесконечный на e степени минус b квадрат, деленное на единица плюс b квадрат l квадрат. So let's start. As you remember, effective multiplication factor could be found according to the formula, to the up and top formula. It's infinity coefficient multiplied by 2 non-leakage probability, for thermalization and for the diffusion, Do you see my screen?
Yes, Doc.
At the same time, we can find effective multiplication factor by the second formula, This is E, exponent, and b in square, multiplied by h divided by 1 plus b quadrat l quadrat. So, possibly, this multiplication is here, so we can rewrite that probability of non-leakage during the thermalization can be found as the top member E minus B in square multiplied by tau. So non-leakage for diffusion will be 1 divided by 1 plus B in square and L in square. So tau it's H, L it's diffusion length, and what is the B?
Buckling.
What kind of buckling? As you remember, there are two types of buckling: geometrical buckling and material buckling.
I think geometrical.
It's material buckling. And at the same time, you remember the equations for criticality, It's the ratio between two buckling, So at the same time, this formula for effective coefficient, we can simplify, and it depends on the values of H and diffusion length. So if the diffusion length in square is really higher to H of neutron, we can use the following expression for B in square. B in square equals K infinity minus 1 divided by migration length in square, as I remember, it's necessary to check. And if the L in square is really low, then tau. So B in square, it must be M in square, equals ln K infinity divided by M in square. Do you remember this formula? I think Mr. Kuznetsov gave you this two simplifications.
Yeah.
But in these cases, you have to know what is the migration length, what is the L and tau. So therefore, sometimes it's necessary to calculate if you want to calculate buckling. So at the same time, can I delete everything?
Yes, Doc.
Okay. So at the same time, yeah, for cylindrical nuclear reactor core, yeah. So this is the radius, yeah, and the height. So for the cylindrical, the buckling in square equals P divided by H in square plus 2.405. It's the first root of the Bessel function, yeah, divided by R in square. And you can use centimeters or meters, and the answer will be 1 divided by centimeter in square or 1 divided by meter in square, yeah. So minimal critical volume for this type of the reactor, yeah, could be calculated according to the formula. It's 148 divided by P in cubic. So if we used the reactor with reflector, yeah, at this part we have to add reflector savings, yeah. So the neutron flux as a function from R and Z could be found as a function f0 multiplied by Bessel function 2.405 divided by R and R multiplied by cosinus function P, H, and Z. Yeah. So this is for cylindrical type nuclear core. Now I have to
Dr. T over H.
Where? Could repeat.
The last symbol cosine.
P, H, and Z. Z. This is a distance. Yeah. The distance of the point. It's coordinate of the point. I mean R and Z. So for the spherical type, right? So this is the radius. Yeah, the B in square equals P over R in square divided by 2. And the critical volume is 130 divided by B in cubic. The flux in these cases will be simpler. R divided by P R multiplied by, I forgot the function, sinus. P R multiplied by R. Yeah. And the last cases is for parallelepiped. Yeah. So for parallelepiped, it's A size, B size, and C size. For parallelepiped, B in square equals P A in square plus PB in square and plus P over C in square. It's really simple to calculate for cubic nuclear core. Yeah, in this cases, A, B, and C, both of them has the same value. Yeah. So the neutron flux looks like it's a function of 3 coordinates: f0 multiplied by cosinus of p a x plus multiplied by cosinus of pb, it's y, and multiplied by cosinus p c multiplied by z. Yeah. So possibly all of this equation will be necessary for calculation. Okay. Any questions about these formulas?
Doctor, could you give us a short description about the difference between buckling material and geometry? Because I know just the buckling of geometry.
Okay, so we have two constant. It's I forgot epsilon, as I remember, yeah, and b. So epsilon is geometrical buckling, geometrical. B is material. So possibly, if you want to obtain criticality when effective coefficient equals 1, we can use two cases. Yeah, the first one, we have to use appropriate geometry, and the second one option is we have to use appropriate materials. Yeah, so it means that if you want to create reactor, yeah, for example, cylindrical reactor, yeah, it doesn't matter for us what kind the size of the nuclear core, but we can find appropriate concentration of different elements, yeah, and you will obtain criticality. But at the same time, if we don't know the concentration, but we can find appropriate size, appropriate dimensions, yeah, and we can obtain criticality. So this is two options. Yeah, and at the same times, both of this coefficient, yeah, if we use in square, has the dependence. So it means that sometimes we can change geometry, and it looks like we can change the material parameter, yeah, material structure of the nuclear core, or we can change the structure, material structure, yeah, the concentration, and it looks like we change the geometry of the nuclear core. So this is two main factors of the reactor's creation. So this is two members that can explain different features of the nuclear core, yeah, but at the same time, it explains the influence from one option to another option. Do you understand what I mean?
Yes, thank you.
Okay. It's the same as for reflector, yeah? As you remember, for lab performance, I asked you when it's happened, when we can obtain this picture. Yeah, if this nuclear core and the second one is the reflector. And you can say me that firstly, we have to use appropriate materials. Yeah, it's the B. So if we use the deuterium water, yeah, we can find this distribution of neutron fluxes, of neutron thermal flux in the reflector. Yeah, just because the deuterium water doesn't have any ability to absorb neutron, to neutron absorption. But at the same time, yeah, if we don't use deuterium water, it doesn't matter for us. Yeah, if it's light water, ой, господи, H2O, yeah, we have to decrease the size of nuclear core. Yeah, it's the it's kappa, it's not epsilon, it's kappa. It's kappa parameter, geometrical buckling. Yeah, so it means in these cases, if the nuclear core will be very small, the neutron do not have good ability for moderation. And in these cases, the biggest part of the moderation will go in the reflector. Yeah, so therefore you will obtain this picture. So in these cases, we change geometrical buckling instead of material buckling. Yeah, so it shows you that sometimes you can change geometry and do not change the material balance in the nuclear core. Yeah, but sometimes you can change materials in the nuclear core. Yeah, but do not change geometry. Okay, so the first task, a typical composition for PWR is following. So PWR. And this is a composition. I mean the elements in the nuclear core. So it has an H, an oxygen. Yeah, just because we have the heavy water or light water. For construction material, we have to use zirconium alloy. This alloy contains iron. At the same time, we have the fuel. Our fuel is UO2, so we have uranium 5, uranium 8, yeah, oxygen, the concentration of oxygen in the fuel goes to this part, and at the same time, раз, два, три, четыре, пять, and at the same time, for control rods, yeah, we just use boron 10. So according to the task, we know all concentration of the elements in the nuclear core. So the concentration of hydrogen is 2.75 multiplied by 10 powers 22 nuclei per centimeter in cubic. For oxygen, it will be 2.76 multiplied by 10 powers 22. For zirconium, it will be 3.69 multiplied by 10 powers 21. For the iron, concentration is 1.71 multiplied by 10 powers 21. For uranium 5, the concentration must be lower, yeah, multiplied by 10 powers 20. For uranium 8, it will be 6.59 multiplied by 10 powers 21. And the concentration of boron 10 is 1 multiplied by 10 powers 19. Okay. So,
Okay.
do you write these values? Yeah, just because I need to delete everything. Do you rewrite?
Yes, yes, yes.
Okay. So, the transport cross sections for the elements, transport cross section. Yeah, I simplify for you. It's not necessary to calculate. Is the following. It's 0 point in barns, yeah? 0.65. And for the next classes, yeah, for your exam, for your future calculations, you can use these transport cross sections. Yeah, I found in the table For oxygen, it will be 0.26. For zirconium, 0.79. For the iron, it will be 0.55. For uranium, it's just 1.62. For uranium 8, it will be 1.06. And for the boron 10, it's 0.89. So we know the typical composition for the PWR reactor. We know the cross-section, transport cross-section. So it's necessary to calculate the critical radius. It's necessary to calculate critical radius for the circular cylindrical bare core with fixed height. And the height is 375 centimeters. So it's necessary to calculate critical radius for this type of the reactor. That's all.
Okay.
It's the reactor. Reactor core.
Cylindrical.
So how much time is necessary for you to calculate? Так, у нас 13:02.
According to Dr. number of the tasks.
3 tasks to this.
Okay. We divided the time according to tasks.
Okay, so I'll give you 15 minutes for calculation. It's very simple. You have the formulas. Yeah, you know the buckling. You can calculate the buckling. You know the formula for buckling. You can obtain the radius. Yeah, just because everything is.
Okay.
I mean the age. You have the age. The biggest problem, yeah, it's necessary to understand with diffusion length and with age what kind of formula you have to use to simplify. Another option, yeah, it's necessary to calculate infinity coefficient of multiplication. In these cases, yeah, as you remember, mu multiplied by phi equals 1. So just use theta coefficient and eta coefficient, neutron thermalization factor and eta constant for calculation. That's all. Okay, I'll go smoking. And you have
Okay, Doc.
12 minutes. Бабушка у меня, блядь, я в 7 утра разбудила, ей телефон настроил. Такая счастливая. Вот ты не новый. Что ты это считай? 3 года назад это был топ. Но она теперь туда считает плохой. Лерка у нее забрала этот OnePlus. Только Лерка же на телефон определяет, она бедная не понимает, что на старом у нее было 4500 мАч. И батарейку он держит лучше. Сейчас она увидит, что такое за игрушку, за час разрядится полтелефона. Как звонит, так он нормально. А вот если не уладит, то не очень. А, вот точно. Она вообще рассчитывала, что она мой заберет. Не, ну слушай, во-первых, ей я бы не отдал, ей по башке бы стукнули. Ну, да, в легкую. А бабушка посмотрела мой новый телефон и говорит, ты что-то мне херню какую-то, давай мне этот. Я говорю, нет, мать, ты не заслужила. Он говорит, ладно, я согласна на то. Недовольная вот это вот. Давай сделай. Нет, и было вот это, сделай мне. И думаю, господи, дитятка маленькая. Ой. Так что вот так вот. Настроил я чатик. И там еще 1200 пришла доплаты. Все, она теперь это богатый человек. Пачка 150 рублей, как на 10. Я не знаю, ты хотел менять, но по-моему. Я план на 20-й год, я же не видел. Там мы хотели поменять на этот, на СВРК вместо скут. Да. Я уже путаюсь. Ну, пусть так будет, господи, все равно буду рассказывать про все. Скут, наверное. Ну, слушай, я сейчас не посмотрю. Я сейчас, если этот переподключусь, оно это... У меня практика слетит. Система внутри... Да, там СВРК. Ну, господи. Че он? Чтоб с работы отпустили. Значит, как я понимаю, оплачиваемый день. Вот так вот, Михаил Сергеевич. Ну ладно, давай потом звякну. It's necessary to remember to tell Mr. Kuznetsov about the middle of the June.
Yeah, okay, Doc. I sent you.
Yeah. I saw your message here. So after the classes, I called to Kuznetsov and telling him information that he is a bad teacher. Так, Andrew asked me about the likes to schedule to correct lab defense on Wednesday at 12. Wednesday at 12. У меня совещание. Wednesday it's среда. Yeah. On the evening.
Yeah, Doc. On Wednesday, I would also like to defend.
Wait a second. Evening. Let's do it at 6 p.m. I have to write Andrew at 6. Where is my list? Where is my student schedule of lab exception? Oh my god. Так. Среда. Так, на вторник. Среда 18:00. Andrew. So, Dominique, what is your question?
I want to know whether is there space on Wednesday?
Space and at the date?
Yeah.
So it's possible to do tomorrow on the second part of the day, just because on the morning I'll go to my job. It's necessary to help Mr. Dalmatov. I think after the 3 p.m. Is it okay? 3 p.m. for you?
Tomorrow?
Yeah.
Doc, I mean, they are relocating us from this hostel. So they want me to relocate to another hostel because they want to relocate here. Hello? So even today now, the hostel administrator, I'm
Okay.
having so
it's possible to do on Wednesday at 6:30.
Okay.
Так. Yeah, just because at Wednesday I have classes and I have the meeting at the 10 building.
Doctor, you speak about the lab defense? Or what?
Yeah. Так, Dominique at 18:30. And please remember me on Wednesday. Yeah, send me a message that today we have the lab defense at this time, okay? Just because
Doctor, what about the Wednesday in 3 p.m.?
at 3 p.m. I'll be at 10 building on the meeting.
Because I think the previous lecture we agree about we will defense about research report.
So let's move it on 4, okay?
4.
Yeah.
At the same time, we have a defense of nuclear fuel cycle presentation project.
Yeah, I know. Yeah, we start with defense of the nuclear fuel cycle presentation, yeah? And after that, we will start with defense of research paper.
At Wednesday at 4.
At 4, yeah, instead of 3. Yeah, just because today on the morning, I obtained the message from main building about the meeting. Oh. And who is your supervisor? Still live? So just write the message to Yulia, and I think she will help you. Okay, guys, it's necessary to do reconnection. Okay.
Okay.
Yes. And the last person. And So let's start to solve the problem together, okay? So firstly, yeah, it's necessary to calculate age and length of the diffusion. Yeah, just because it's necessary to choose which formula we have to use for B. Possibly, yeah, it's necessary to remember the values of age and length of the diffusion for different elements. Yeah, so in our cases, it's PWR reactor. So it means that thermalization happens in the water, yeah, just because water is a moderator. And the diffusion length, yes, the biggest part of the diffusion length will be again connect with the water, yeah, just because this media has the biggest volume. So just remember that H for the H2O, yeah, is near 30 centimeters. I don't remember the real values. It may be 31 or 31.2, yeah, but it's really close to 30 centimeters. So diffusion length, not diffusion length in square, yeah, is 2.71 in centimeters. So H for beryllium is approximately close to 90 centimeters. And tau for carbon is really huge. Yeah, as I told you, graphite reactor has the biggest size. So it's 350 centimeters. I repeat for you, it's not the 100 accurate value. Yeah, it could be 356, 357, I don't remember, yeah? But for calculations, for understanding, yeah, you have to remember these values. It's near 350, I think it's simpler to remember. Okay, so the L, the diffusion length for beryllium is near 20 centimeters. And for the carbon, L for carbon, for beryllium, and light water. Yeah, and for the carbon is approximately 50 centimeters. So now we have to use ln squared. So 2.71 multiplied by 2.71, it's almost 3. 3 and 3, it will be 9. So it's near the 8 centimeters, yeah? In this case, it's 20 multiplied by 20, it will be 400. And, 20 дважды 24, да, 400. And for 50 centimeters, yeah, it looks like 2,500. In our cases, we used light water reactor. Yeah, it's PWR. So it means we have to understand which characteristic is higher, is really higher, tau or L in square. In our cases, for PWR or for VVR, we can see that tau is really higher than L in square. Yeah, the H is bigger compared to diffusion length in square. Yeah, so therefore, for our calculations, P could be calculated as a function of ln k infinity divided by migration length. Do you agree with me?
Yeah.
Yes.
Yes.
Okay, so now it's necessary to calculate infinity multiplication factor. So as I told you, this multiplication equals 1, multiply by theta and multiply by eta. Or I can rewrite for theta coefficient, yeah, I have to use on the top place macroscopic cross-section of absorption for uranium-5 and for uranium-8, yeah? So it will be N5 multiplied by absorption for U5 plus M8 multiplied by microscopic cross-section of absorption for uranium-8. For the bottom place, I have to put macroscopic cross-section of all elements. So it will be N5 micro 5 plus N8 micro absorption 8. Yeah, it's 8. Plus hydrogen NH multiplied by hydrogen plus oxygen plus zirconium multiply by iron, plus, yeah, concentration of iron. I don't know why I use small f instead of big F, but I think you can understand me. Microscopic cross-section of absorption for iron plus, and the last one is boron, plus, and boron multiplied by microscopic cross-section of absorption for boron. And at the same time, we have to multiply by eta coefficient. So it will be nu F5 multiplied by ratio. In our cases, only one element can be divided by thermal neutrons, yeah? Can produce fusion reaction, it's just uranium-5. So it will be the ratio between two microscopic cross-section. On the top place, we have to use fission for 5 and over absorption for 5. Please, guys, calculate the infinity and multiplication factor.
Doctor, excuse me, we will use the microscopic cross-section of transportation instead of fission and
No, of course no. So the next step, yeah, it's necessary to calculate migration length, migration area. So migration area is the sum of h and length of the diffusion in square. So the length of the diffusion can be calculated via transport cross-section. So therefore, I show you the different values of the cross-section. In these cases, it's necessary to open tables and find appropriate cross-section of absorption. As I remember, for oxygen, it equals 0. So guys, do you calculate? Or you need extra minute?
We need the extra minute, doctor.
Okay, I'm waiting for answer.
New fission, doctor, is given.
What?
New fission.
New what?
New fission.
Fission.
New.
You mean this one? New fission. Yes.
Fission.
As for me, it looks like new. Yeah, something new. Yeah. New fission? What kind of fission?
Yes.
New fission coefficient. Yeah. When you open the table of the cross section, yeah, for thermal group you can find the value for uranium-5. As I remember, it's 2.42 or 43.
Okay, thank you.
It's necessary to check me. I forgot to drink my pills. Give me 3 minutes. Папа, у меня пара идет. Я тебе после пары перезвоню, это где-то через час. Угу, хорошо, давай. So, guys,
I don't found the zirconium, doctor, from tables.
it's give me a second. Так. You mean the microscopic cross-section of absorption for zirconium,
Yes.
yeah?
Yes, yes.
Па-па-па-па-па-пам. Так, введение, где она у меня теория? Так, табличка. It's necessary to find the table. Вот это. I don't have déjà vu. Блин. Пу-пу-пу-пу-пу. Так. Течение поглощения циркония. So, zirconium has really low cross-section of absorption for thermal neutrons. So, therefore, in this cases, just take 0.
Oh, I found it, doctor. It's about 0.185.
Oh, and I found 0.18. Yeah.
Just a minute for calculation.
And hurry up a little bit.
Doctor, it's about 1.5.
It's 1.5. Yeah.
Yes.
Okay, so let's take that as the infinity coefficient equals 1.5. Okay. Okay, so give me a second. The next step, yeah. So we calculate k infinity equals 1.5. Yeah. So the next step. So basically, yeah, it's necessary to calculate h of neutron in light water and L in square in light water. Yeah. Do you remember how to calculate it? So possibly, yeah, for this calculation.
Doctor, we calculated before in the section, I think 2. It's about diffusion length square for H2O. It's about 5.866.
Mm-hmm.
And the age, it's about 35.8 centimeters.
35.
35.8.
Mm-hmm. So you know how to calculate. Yeah, could you repeat? The age is 35?
35.8.
36, yeah?
Mm-hmm.
And L in square?
5.866.
5.9.
Okay.
Yeah, it's point.
Centimeter square.
Yeah. Everything will be a centimeter in square. Okay. Yeah, so it's the same as for previous classes, yeah? So migration lengths in these cases, in migration area, it's the sum of tau and L in square.
And L, yeah.
So migration length will be 36 plus 6, it will be 42, yeah? 41.9. It's just 42. It's simpler to use for calculation. Yeah, but of course you have to take 41.9 for better result. So we obtain, yeah, the migration length. So B in square equals ln k infinity divided by migration area. Could you calculate, please?
It's about 9.6.
9.6.
Multiply by 10 minus 3.
9.6, yeah, multiplied by 10 powers minus 3 in centimeters in square. So at the same time, yeah, according to the geometry of our nuclear core, it's cylindrical. Yeah, so it looks like 2.405. We have to divide it by radius in square plus P divided by H in square. So according to the task, we have to calculate radius, critical radius. Yeah. And at the same time, we know H. So let's find the H. Так. So it will be P H in square equals B in square minus brackets with R in square. Yeah. So P H. Так, кто там? Блин, give me a second. Что такое? Что-то срочное? Ага. А как тебе надо? Хорошо, сделаю. Угу. Хорошо. После пары, Оль. Угу. Хорошо. So, sorry, guys. We need radius. So it will be H here and radius here. Yeah. So I'm sorry. It's my phone. So it will be 2.405 R P and H. P and H. 2.405 and R. So R in these cases it's 2.405 divided by the root. Yeah. So could you calculate the answer?
The X, doctor, is 375 in centimeter or in meter?
In centimeter. On previous classes, on previous course, we discussed the size of the core for BWR and for and for VWR. So it's near 4 meters.
Okay.
It's around, doctor, to 513.
13.
13.
200. 230.
500.
500.
And 13.
513.
13.
Mhm.
Or 30.
13. 513.
513. Why 513 centimeter? It's really a little bit huge compared to real values.
Yeah.
But in real life, yeah, it's necessary to calculate mu and phi coefficient. Yeah, we just simplified just because for the phi coefficient, yeah, it's really hard to calculate the resonance integral, and for mu we have to know the real values of the fuel rods. Yeah, just because the mu coefficient is really depends on the radius or diameter of the fuel rods. Yeah,
Doctor,
we
what is
don't know.
the real value of the radius?
You have to check my
How it works?
lectures. Just because
About,
after 1 or
let's say.
2 weeks you have the exam.
Okay.
Okay, so guys, do you understand the principle of the solution, how to solve? I think it's not so hard. Yeah. Okay, so the second task: calculate critical volume and radius for sphere from pure uranium-5. From pure uranium-5, if the density of U5 is 18.9. Do not use fission of fast neutrons. Yeah, so it means it's necessary to use just thermal groups. So it's necessary to calculate. It looks like you create a nuclear bomb. Yeah, you have to take a sphere from uranium-5 and find the critical volume and critical radius. So we have 12 minutes, so you have 10 minutes for calculation. Or if you want to, yeah, just because we have only 15 minutes, we can do it together. Let's do it together.
Yeah.
Okay.
Okay, that's fine.
Real, it's
So we can sit home and then revise and do more exercise.
Yesterday I calculate 2 tasks. Yeah, the second one and the third one for the 2 hours. So therefore I don't calculate the first one.
Okay.
Okay, so we have a sphere. Yeah, so the critical volume in this case is 130 divided by b in cubic. Yeah, it's really simple to calculate the radius if you know the volume. Yeah, how you can find the radius? I'm waiting for formula. Do you remember how to calculate the volume of sphere?
Volume
It's
of a sphere.
4p in cubic, 4p r in cubic. Yeah, so it will be volume divided by 4p. Yeah, so it's necessary to calculate b. B in square depends on the h and the diffusion length again. So now it's necessary to calculate h of neutrons in pure uranium-5 and lengths of diffusion in square. Yeah, and after that we have to compare which one is bigger. And after that we can find the equation for B. Okay, so Firstly, let's find the L in square. L in square for U5. How we can calculate it? It's 1 divided by 3 macroscopic cross-section, transport cross-section, multiplied by microscopic cross-section of absorption. Yeah. Or I can rewrite it's 1 divided by 3 macroscopic cross-section of scattering, multiplied by macroscopic cross-section of absorption, and multiply 1 minus cosinus mu. Yeah. And cosinus mu, we can calculate it as 2 divided by 3 divided by A. So guys, it's necessary to take macroscopic cross-section of scattering and macroscopic cross-section of absorption. As you remember, all of you have to create the table, yeah? So
Doctor,
what
we
is
take the transportation, microscopic transportation in the given, or this previous task, related to previous task? Or?
So in these cases, it's necessary to calculate the concentration. Yeah, and after that, it's possible to find it. But I think it's simpler when you use this equation. So what is the macroscopic cross-section of absorption, according to your calculation, from the table for U5? Or we don't have? Just check your notes.
683 microscopic.
Macroscopic. I'm
Macro?
interested in macroscopic.
Macro.
Micro you have to take from table. So maybe we don't use the pure uranium. So it's possible to calculate, yeah? So firstly, it's necessary to calculate the concentration of uranium-5. How we can do it? It's necessary to take the density of U5, Avogadro number, and divide it by 235.
Yeah.
So I calculated it was 4.85 multiplied by 10 powers 22. Yeah, it's for pure uranium-5 without uranium-8. So when you take all cross-section, yeah, when you calculate a number, cosinus mu, so L in square in these cases will be, according to my calculation, is 3110 centimeters in square. Give me a second. Что такое? У меня пара. Алло? Нету, значит, нет. Okay. So the next option, yeah, it's necessary to calculate tau. person. We missed the last person. So it's necessary to calculate the age. Yeah. So for age calculation, yeah, you can use the formula. So I a little bit simplify it. Yeah, just because, as you remember, it's necessary to put xi and so on. It's 3, 1 minus 2 divided by 3a. It's 1 minus cosinus mu multiplied by s. Yeah, it's a transport. Блин, где? Так, я принял? Да, Prince. Yeah, Prince is here. And multiplied by ln e divided by e thermal. So this is will be 2 mega MeV, yeah, to 0.025. So in this case, tau will be 255 centimeter in square. So in these cases, I use a little bit another formula. So sometimes it's very simple to use this formula for calculation. Okay? So
Okay.
therefore, m in square, both formula are useful, yeah, but in this case it's simpler. It will be m in square, so it will be the sum of l in square plus h, and it will be 3,300 65 centimeter in square. So we calculate the L, we calculate the tau, and according to our calculation, yeah, L in square is really bigger compared to tau. Yeah. So
Yeah.
therefore we have to use another option for b in square. Yeah, it will be k infinity minus 1 divided by migration area. Migration area we calculated yet. Yeah, we have calculated yet. If used more better English. So the next step, it's necessary to calculate k infinity. Yeah. So as I told you, mu and phi equals 1. Yeah. So what's about the theta coefficient? It's the ratio absorption in the uranium divided by absorption of all materials. What is the value of theta coefficient for this task? It's the absorption in the uranium, in our cases, in the uranium-5, divided by absorption in all materials. And we just have one material, uranium-5.
Equal to 1.
Of course, just one. So it's necessary to calculate eta. And eta in these cases, it will be the constant. Please calculate it. Господи, то звонят, то пишут. Ой. So eta in these cases, it's a coefficient, so it's nu f5, and the ratio between two cross-section f of uranium-5 and a of uranium-5. Yeah, just because in these cases we just have one type of the fuel. Yeah, it's uranium. We don't have plutonium, and it will be the 2.046.
662.
62, yeah, 62 or 2.06. Yeah, I think it's enough. So b in square in these cases, yeah, we just have to put appropriate values. Yeah, b in square in this calculation will be 0.000032. So therefore b will be 0.018. Okay. So the next option, it's necessary to calculate volume. So the volume will be, yeah, it's necessary to take 130 divided by b in cubic. Volume will be 2.2 multiplied by 10 power 7 centimeters in cubic. So, and radius finally will be 174 centimeters. Okay?
Okay.
Подождите вы, у меня занятие. Okay, so, and the third task will go to your home. Are you ready? Just try to solve, yeah? Да что ж такое сейчас? Give me a second. I show you the answer, yeah, and you can check yourself. Find the critical size of the reactor core as a cube. Give me a second. У меня за пару 4 звонка, 3 звонка в двери, 15 сообщений. У меня пока пара идет. Дайте я задачку продиктую. Я перезвоню, да. Хорошо, сейчас. Oh my God. So find the critical dimension or critical size of the reactor as a cube shape with graphite moderator if K infinity equals 1.06, the H of the carbon is 850. It's just the values for this task. And L in square is 250. So it's necessary to calculate volume and the size, yeah, and the size of the cube, and A, B, or C. And please try to do it at home, yeah. The answer, the minimal critical volume will be 1.3 multiplied by 10 powers 8, and the A, the side, yeah, is 314 centimeters.
For cubic, for doctor.
Huh?
For cubic?
For cubic, yeah, cubic shape. I gave you the formula for parallelepiped, yeah, but parallelepiped has 3 equal sides. Yeah, so in this cases it will be you just have to take 3A. Yeah, I think it's really simple to calculate. Please check yourself at home, okay?
Okay.
Okay, Doc.
Any questions about this task?
Thank you very much.
Thank you.
No question. So guys, I'll wish you good luck on the exam with Mr. Kuznetsov.
Thank you for supporting doctor and for helping.
So if you have question before the exam, yeah, you can send me a message and I do all my best for helping.
Okay.
Okay, guys. So I have to go to call. So good luck, guys.